Welcome back. Today we're going to talk about formulas in 3 dimensions. And what we need to understand about formulas in 3 dimensions is that we're dealing with polyhedrons. A polyhedron is a 3D figure formed by 4 or more polygons that intersect only at their edges. Okay, so they only intersect at the edges. Some examples of polyhedrons would look like this. I could have a square prism, or perhaps a square pyramid. Things like that. Prisms, pyramids. Those are formed by polygons, which are shapes with straight sides, that intersect at only the edges. Noddihedrons. Things that are not polyhedrons would be cylinders, cones, or spheres. Okay? So cylinders, cones, and spheres are not polyhedrons because they have curved sides. They are not all polygons. And so Euler was a guy who was a mathematician, and he came up with a formula for finding the number of faces, edges, and vertices. So F equals faces, E equals edges, and V equals vertices. Not too creative there. And his formula says this: vertices minus edges equals face, or plus, put equals, plus faces equals 2. So when we take the total number of all these things for a polyhedron and we take vertices minus edges plus faces equals 2, that's his formula. And so if it's a polyhedron, then this is going to fit. And so what we do with this is we're going to find the number of vertices, edges, and faces, and we're going to use our results to verify Euler's formula. Or some people call him Euler, okay? And so when I look at this triangular pyramid here, you can kind of see the backside. Sort of looks like this, and it's a triangular pyramid. If I'm talking about faces, that's 4 because it's 1, the yellow is 2, the backside is 3, the bottom is 4. And the number of edges would be 1, 2, 3, 4, 5, 6. And vertices is equal to 4. I'm going to verify that vertices minus edges plus faces equals 2. Let's check it out. 4 minus 6 plus 4 equals 2. Negative 2 plus 4 equals 2. Check. So this works. I know I counted correctly. Okay? Let's look at this pentagonal prism. Faces equals 1, 2, 3, 4, 5. So 1, 2, and 5 would be 7. Edges would be 1, 2, 3, 4, 5. 5 and 5. I like to think about it as the number of sides on the base, so 5, the number of sides on the other base, which would be 5, and then each of those vertical sides would be another 5, so that's 15. And my vertices is going to be 5 and 10. And so when I do vertices minus edges plus faces equals 2, I'm just going to fill it in. 10 minus 15 plus 7 equals 2, minus 5 plus 7 equals 2, and so it fits. Okay, that's Euler's formula. That's all we're looking at, faces, edges, and vertices. And so I want you to take a look at these two and tell me what you think. Count up the number of faces, edges, and vertices, verify Euler's formula. Okay, thanks for watching, guys. We'll see you next time.